Hello everyone, myself Nisha, and today I will be giving a brief overview on buoyancy, which is a very common phenomenon and quite interesting also. Okay, let's start with few observations. Have you ever had swim in a pool and felt lighter? Have you observed the ice cube floating in water? Let's take another example. Have you ever wondered why a ship made up of iron and steel doesn't sink in seawater, but while the same amount of iron and steel in form of a ship would sink? These questions can be answered by taking buoyancy in consideration. Let us see how. Let's take a sponge ball and put it in a bucket filled with water. Okay. Here we will consider three different cases. Okay. Now let's understand these cases. You will see that the ball floats. If you try pushing it down, okay, you will find it difficult to push. If you further try to push it deeper and deeper, okay, it is very difficult then. That is because the upward force goes on increasing till the ball is completely submerged. Okay, the ball floats. The gravity is pulling the ball by gravitational force, which is denoted by Fg, fine, and the upward force is denoted by F1. In other cases also, the gravitational force is denoted by Fg and the upward force is denoted by F2. In third case also, the upward force is denoted by F3 and the gravitational force is denoted by Fg. The gravity is pulling the ball by the gravitational force, but the ball floats due to upward exerted force by water. Now let's try to push the ball further down, as in this case. You will observe that as the ball is pushed further down, it will be more difficult to push it because the upward force keep on increasing till the body is completely submerged. So it means F3 is greater than F2 is greater than F1. Fine. Now let's release the ball. When we release the ball goes up. We know that the Earth's gravitational force is pulling the ball downward. Okay, but then why the ball is going up? That's because the water exerts the upward force on the ball. It is exerting the upward force on the ball actually. Thus the ball pushed upward. We have learned that the weight of an object is a force due to gravity. When ball is immersed, the upward force exerted by water on ball is greater than its weight. Therefore, it rises up when released. The upward force exerted by water on ball is known as upthrust or buoyant force. Here, F1, F2 and F3 are the buoyant force or the upthrust. The magnitude of this buoyant force depends on the density of fluid. To understand it more clearly, let us take another example. Now we will consider a case of coin. this case also, the gravitational force is acting represented by Fg dash, and our upward force is acting on the coin, which is represented by F1 dash. Fine. What we will see that the coin sinks. The earth pulls the coin downward, and there is also the upthrust of water on the coin which pushes it upward, but the downward force of gravity is greater than the upthrust of water. So coin sinks. Okay. The ball floats while the coin sinks. This happens because of difference in their densities. What is density now? The density of a substance is defined as the mass per unit volume. The density of ball is less than the density of water, so it floats. And the density of coin is more than the density of water, that's why it sinks. Alright, we now know about the buoyant force, but what is the magnitude of buoyant force experienced by a body? Is it same in all fluid for a given body? Do all bodies in a given fluid experience the same buoyant force? The answer to these questions lies in Archimedes' principle, which says when a body is immersed fully or partially in a fluid, it experiences an upward force that is equal to the weight of the fluid displaced by it. So now you know why the object weigh less in water, some floats while other don't. Archimedes' principle have many applications like designing ships and submarines. Okay, so I think that will be all for today, and hope you have liked this session. Thank you and have a nice day.